Guess it's going. All right. We had quiz 3 preview. We have a quiz on this mañana. Tomorrow. All right. You may wish to write down the format for these are absolute value graphs that we're starting with. A times x minus h plus k, where h and k are shifts horizontally and vertically. Identify the vertex, the slope of the branch, and graph the following functions. Now, it's the slope of the right branch only. Right branch. Okay, so that would be -3, the a value. The vertex here, h would be 0, and k is 7, so the vertex is at 0, 7. You were supposed to have done this, so an awful lot of writing going on. Hopefully you were just checking it, but this vertex is actually off the graph. Down 1, 2, 3, right 1, down 1, 2, 3, right 1, etc. And then that's your right branch. Sorry, that one was, oh, I didn't hit that very well. Oh, well. That's the right branch. And then to do the left branch, and I know I'll have someone in here tomorrow make a line, and that's it. That won't cut it. The left branch will be down 1, 2, 3, left 1. Down 1, 2, 3, left 1. And that is your V. It's a graph. We called it a V. I am not getting a very good line drawn, but that's all right. We'll figure it out. Okay, the next one, we have y equals the absolute value of x plus 2 minus 3. So the vertex h is at -2, because it's supposed to be minus h, and -3 for the k value. The slope number is 1. It's in front of the absolute value bar. So -2, -3, and then up 1, right 1, up 1, right 1. That is your right branch. And I want you to continue it to fill the graph. I don't want little stubby graphs. Up to left 1, up to left 1 for the other branch. So you should get a V. Oops. Okay, number 3, you've got a vertex at 3, -1. A slope of 2/3 for the right branch. So you go to 3, -1. From there up to right 1, 2, 3. Can't make any more of those. And up to left 1, 2, 3. And that I can do a few more points. Okay. All right, next, number 4. Oh, that's not number 4. Is this your number 4 with the graph? I just added those in. It's this. Got it. Okay, this is a step function, which means it's going to have stairs. This one will have 2 steps between each of its stairs. If you put in 0, you get 0. When you get over to 1, you have an open hole, because when you evaluate the step function or round down function at 1, you would get -2 times 1, which is -2. So the stairs are coming down. And then we're going to go in reverse to get the full graph. I expect you to have the whole graph done. So those are the steps you can fit on here. Second one, or the second step function graph, if you put in 0, you get 1. So your stairs were shifted up 1 from the parent graph. And there's 1 space between each of them, because the value in front of the greatest integer is 1. The coefficient. I can get 1 more point right up there, but I can't extend it. I'll come backwards. Okay. And there wouldn't be anything there because an open hole doesn't count. Six says find for the given value of x, f of 1. You have to look at the restrictions. This is a piecewise function. The first equation is used if x is less than 1. The second equation is used if x is greater than or equal to 1. So the f of 1, you would use the second equation, which would give you -1 minus 3, which is -4. The f of -2/3. -2/3 is less than 1, so you would use the first equation. So we would need to do 2/3 times -2/3 plus 2. 2/3 times -2/3 is -4/9 plus 2. If I get a common denominator, 18, over, I don't know what I just did. 18, I put the numerator on the bottom, and I need to change that to a 9. So 18 divided by 9 is 2, so 18/9 is the equivalent of 2. So now if I add, I can subtract the numerators, or add them, if you will. -4 plus 18 would be positive 14/9. Needs to be a fraction answer, not a decimal. Okay, the f of 4. 4 is bigger than 1, so use the second equation to be an opposite of 4 minus 3, which would be -7. Okay, I've got a piecewise function to graph next. So the first equation, y is equal to -2x plus 4. Think of it, I'm going to just start doing a t-chart. I'm going to put in the boundary number of 2. You can highlight that if you like to highlight it. I'm just going to do it without it. I'm going to put 2 into the first equation. That would give me -2 times 2, which is -4. -4 plus 4 would be 0. I need another number less than 2, so I'm going to go ahead and put in 1. That'd be -2 plus 4, which is 2. And maybe if you wanted to put in one more, like 0, you'd get 4. So I know that at 2, 0, I have a solid dot because it includes that point. 1, 2 is the next one, 0, 4. And that slope was down to right 1, so I can go in reverse up to left 1 if I want to get some more nice points. And this is that piece of the line. You don't go any further because it's stopping at 2. The second piece of the line, I'm going to plug in 2 as well, even though I know it's not including 2 by the x is greater than 2 symbol. I will have an open dot at that spot though. So if I put in -1/2 times 2 minus 2, -1/2 times 2 is half of 2, which is -1 minus 2. Half of 2 is 1, and you have to apply the negative sign. So that'd be -3. So at 2, -3, I have an open dot. Now I need to put something else in bigger than, 3 would be icky, so I'm going to jump to 4. -1/2 times 4 would be -2. -2 minus 2 would be -4. So 4 -4s on the graph. You could start doing the slope now. You could have already down 1, right 2, down 1, right 2, and get some more nice points. Oops, I'm missing my points. There we go. Try to hit them. I did not do the best job. Okay. Now 10, you must add 4 first. Add 4 to both sides to get the absolute value isolated. So if I add 4 to both sides, I get the absolute value of x minus 6 is less than 5. Then I can write my 2 equations. X minus 6 is less than 5, and x minus 6 is greater than -5. Adding 6 to both sides gives me x is less than 11, and x is greater than 1. So if it's smaller than 11 and it's bigger than 1, it doesn't include either one. If this is 1 and this is 11, it's between there. And it doesn't include them, so it'd be open. You could put an open dot. If on some ways that people graph, they put an open dot. This shows me interval notation 1 to 11. The second one, the absolute value is already isolated on 11, so drop the absolute value bars. Never change what's inside there. but this is a greater than, so it's an or. Negative 3 times x plus 1 is less than or equal. Flip the symbol and change the sign of the 3 to negative 3. We need to subtract 1 and then divide by negative 3. And if you divide by a negative, you flip the sign. So that's going to be x is less than or equal negative 2/3. On the other side, other equation, you will subtract 1, giving you negative 3 times x is less than or equal to negative 4. Divide by negative 3, flip the sign, and a negative over a negative is a positive, so it would be a positive 4/3. X is greater than or equal to positive 4/3. Okay, so negative 2/3 is between 0 and negative 1. And negative 2/3 would be closer to the negative 1. It's including it, so I'm going to put a hard bracket here, shaded left. 4/3 is between 1 and 2. It's actually 1 1/3, so it's closer to the 1 than the 2. It's inclusive, and then shade to the right. All right, so this is 2 tails. From the left side, you always left to right when you name your interval. That's from negative infinity up to negative 1, including the negative 1, so hard bracket. Make sure I can tell if it's a hard bracket or a soft bracket. Union with, I don't know why I wrote negative 1. I think it's because I didn't write the number on the graph. It's supposed to be, the negative infinity was correct, excuse me. It should be negative 2/3. Glad I'm fixing that right away here. Oh, what did I do? Oh, well, I'll just write it over again. Oh, hard bracket. Okay, union with 4/3 to infinity. Okay. All right, next. 12, graph an example of a function that has a domain of 0 to 5 and a range of negative 1 to 4. It includes both endpoints, 0 and 5, includes negative 1 and 4, and it's continuous. So if it's a function, I'm going to make a continuous one. If I look at the domain being from 0 to 5, I stuck a point at 0. Wait a minute, it says the range negative 1 to 4. I'm just showing you, it's got to be between here and here. And then vertically, it's going to be between negative 1 and 4. Okay, so how could I make something that would be fitting that domain and range? Well, there's multiple things that you could do. It's just got to go from as low as negative 1 and not any further to the left of 0. And it's going to come, I don't know, I'm just making something that goes up to there. So I've covered the whole thing. I've gone negative 1 to 4, and I've gone 0 to 5, and I stop. It doesn't have to be this graph. It could have gone from here to there. Okay, it could be a V inside of there. There's lots of things you could draw, but you couldn't do this. How come? It couldn't be something like, correct. It's not a function. It couldn't be this. That would not be okay, because it's not a function. Doesn't pass the vertical line test. Okay, this is on yours, right? This is your next thing? Okay, circles. May want to recall that the format for a circle in standard form, x minus h quantity squared plus y minus k quantity squared equals r squared, where hk is the center of the circle and r squared is, or r is the radius. So this would have a center of 1, 0, and a radius of 3. Plot 1, 0, and then count 1, 2, 3 above, 3 to the right, and 3 to the left, and 3 down. And make a circle. My pen's stuck. Okay, do the other half of my circle. Not perfect, but oh well. This one would have a center at negative 2, 3, and a radius of 2. So left 2, up 3. Then right 2, left 2, up 2, down 2 from your center. Okay, you were actually supposed to be just checking these, not doing them now, but here we go. Moving on, write the equation of a circle with a center at -3, 5 and a point on the circle 1, 2. Okay, so you got your h and your k, so you could actually even start the equation. X be +3 quantity squared plus y minus 5 quantity squared. But you need to find your radius. The radius would equal the distance from the center to that point on the circle. So I'm going to do the distance formula. 1 minus -3 quantity squared plus 2 minus 5 quantity squared. I'm following it where it says x2 minus x1 quantity squared plus y2 minus y1 quantity squared, then take the square root. Okay, so this radius is going to be, that's going to be 4 squared plus -3 squared. And you better realize that -3 squared is positive. That's 16 plus 9, which is the square root of 25, and that gives us a radius of 5. So if the r squared goes here, it would be 25. R squared equals 5 squared, which is where I got that. Okay, next. Graph accurately by completing the table, then plot and correctly connect the points. Okay, this should come out to be a U-graph, a parabola. The domain, you can put anything in you want. Negative infinity to infinity. We've made some suggestions over here for you to substitute in. -2 times -2 squared plus 4. You need to realize that when you square a negative, you get a positive. So that's -2 times 4 plus 4. -8 plus 4 will be -4. If you put in -1, you're going to get -2 plus 4, which is 2. You put in 0, you're going to get 4. You put in 1, you're going to get 2. -2 times 1 squared plus 4. It's again, -2 plus 4 is 2. And there should be symmetry. If you put in 2, you're going to get -4. Okay, and then you want to sketch it, put arrows on it, and try to make it look like it's curved. A U isn't really a perfect description of it, but because U's typically don't keep going wider and wider forever. That's why I don't really like U. Anyway, oh, I like you all, but I don't like that didn't sound right. Okay, so what is the range on this thing? Okay, so you always want to go low, guys, to high. So negative infinity, correct, up to 4. Does it include it? Yes, it does include that point, so you need a hard bracket on the 4. Is it a function? Yep. Yes, and it's 1-to-1? No, because it would not pass the horizontal line test. It's not 1-to-1. And that was the last problem, wasn't it? Okay, get studying. Be ready for your quiz tomorrow. And any questions I will go over now on homework, but I'm going to stop.